Welcome to SPC Insights, where SPC in statistical analysis becomes simple. Today, we'll be telling you the truth about statistical process control. The biggest reason people avoid SPC is because they think they need to be a statistician. But here's the truth. The most important skill in SPC has nothing to do with math. When you use the SPC software, you can ignore all of the statistical and mathematical baggage. All you have to do is interpret the control chart. So let's talk about what SPC really is. As we discussed, SPC is not about formulas. It's about separating process noise from signals. The common cause of variation is the noise. These are normal variations that are always present in the process. Special cause of variation is the signal. Signals are something that is not usually there and not a part of how the process should operate. Think of noise and signals like you would about a sound in your car. Some sounds are normal, others tell you something is wrong. SPC is what helps you tell the difference. Now let's discuss how to interpret the control chart. Control charts are not snapshots. They are like movies. They show what is happening in your process over time. The data is plotted chronologically, which allows you to see the variations in your process. The average is also plotted, so you can see the variation around the average. Control limits are also plotted on the chart. If your process only has common variation present, then the lower control limit is the smallest value you can expect from your process, while the upper control limit is the largest value. If there are no points beyond the control limits and no patterns, then the process only has common cause of variation present, and the process is in statistical control. If there are points outside of the control limits, or if patterns are present, the process has special cause of variation present, and the process is out of statistical control. Remember, the key question when looking at a control chart is the variation normal for the process, or did something change? Congratulations, you've now interpreted a control chart. Now you can plan for your next steps. If there were no signals, then you don't need to do anything. If there was a signal, then it's time to investigate. With SPC, all you need to do is interpret the chart. In order to do so correctly, there are a few more things to keep in mind. A lot of managers accidentally make their process worse. For example, if there is a day when an employee hits a low number, the manager might want to immediately change something, but that actually makes the variation worse. So the process was stable, but then a lot of unnecessary adjustments were made, and now the process is unstable. Avoid tampering. Only adjust the process if your control chart shows a signal and your investigation shows that you need to adjust the process. Now let's talk about specifications and control limits. Specifications are not control limits. Control limits show where the process is at, while specifications show what customers or management want. Control limits and specifications answer two different questions. Control limits tell you if your process is in statistical control. Specifications answer if the process is good enough. When you investigate the results of your control chart, remember the three different types of basic signals. The first, in the best case scenario, is when you find the cause. You notice a point outside of the control limits, investigate it, and discover exactly what happened. Maybe a machine wasn't calibrated correctly. A new operator made a mistake. You remove the special cause, and the process returns to statistical control. That's exactly what SPC is designed to help you do. The second type of signal is a little more frustrating. You see the signal, so you investigate, but you can't find anything. Then, by the very next data point, the process is back to normal. This is what is called a fleeting special cause. Something unusual happened, but whatever caused it is already gone.
While you missed the opportunity to identify it this time, don't panic. If it's truly a reoccurring issue, there's a good chance it will happen again, giving you another opportunity to investigate. The third type is often the most challenging. You detect a signal, but despite your investigation, you can't identify the cause, and the process doesn't return to normal. Instead, it continues operating differently. You might notice a sustained run above the average or a shift in the process mean. At that point, you know something has fundamentally changed, even if you can't yet explain why. It could be something subtle, like a change in raw materials or environmental conditions. In some cases, if the process behavior isn't acceptable, you may decide to adjust the process to bring it back to where you want it. Just remember, that doesn't eliminate the special cause, it simply compensates for it. If that hidden cause eventually disappears, your process could shift right back again. The important lesson is every signal deserves attention, but not every signal has an easy answer. SBC tells you that something changed. It's your job to investigate why.
Thank you for watching SPC Insights. These videos are based off Dr. Bill McNeese's articles on the SPC for Excel knowledge base. You can read them at sbc4excel.com.